Hello and welcome to this BIMLFlex presentation on our business modeling feature. Today's about business modeling and how BIMLFlex makes this easier for you. But what we will really talk about is information modeling. So I would like to start with a quick thought experiment courtesy of Lars Runbeck of Anchor Modeling fame. Imagine there's a thing here. What could it be? Is it an orange dot? And now the thing we were looking at, where did it go? Surely it must be around somewhere. And now it's gone completely. But how do we know? We can only know that a thing existed if we have a record somewhere that it actually did exist earlier. In our case, this was visible a few slides ago, at least in our memory. In addition, we can only assert this by comparing this thing against something else. And this something else must have a different property. Wait a minute, now this thing is back. Or is it? Is it really the same thing? We can't really be sure, can we? Is there a way we can uniquely identify this thing? And if we do identify it, can we match it against our existing records so we can make sure it actually is the same thing? If we look at what we know, the only properties we are aware of is that this thing is round, it's orange, and it pops in and out of existence. So we can start describing these things based on what we can see happening in front of our eyes. But having said that, are we really sure we can classify this thing as orange? What does orange as a color really mean to us? Are we sufficiently precise in our definition of what orange is? And are we on the same page about this? Modeling is about communication at least as much as it is about anything. So maybe we should look a bit closer. And actually, it starts to look more familiar. So as we can see, trying to accurately capture the reality in a model is not easy. A model, at the best of time, is an abstracted representation of reality. And we try to find the right way to describe the reality for our purposes. And this is assuming things will stay the same and that our reality is relatively stable. Even if we do agree on what this thing is at a point in time, this can change, right? We might want to change this into orange juice or into slices. So nothing truly is forever, and everything is constantly evolving. If we look at our IT and business environment, this applies as well. Systems come and go, processes are changing. However, business processes don't tend to evolve as fast as operational systems do. So if you model with a business view, with the business terms and processes in mind, your model will tend to evolve at a comparatively slower pace. Because of this, most people agree that forming a conceptual business view of data is a good starting point for any data initiative. But at some point, you need to be mindful to select the right level of abstraction for your model. And there are many flavors of data solutions we can deliver, but using business modeling techniques is the best way to get the most meaningful data solution for your scenario. Adopting a business model helps to reduce the bias that can creep in some designs. When the design is based too much on how specific operational systems or OLTP applications pull and do things, we might get influenced by the system that we're using and not look at the business context as much that way. But at the same time, we still apply the same data concepts we're familiar with. We still need to solve the same type of problems, just in different ways. Having said that, it will be easier to integrate new systems because even though they might use different names for things, they still largely follow the same concepts, and we can map them to existing concepts more easily. But as we will see, this can be easier or harder depending on your modeling starting point, and this is where BIMLFlex comes in to make it easy for you. In short, we use the BIMLFlex application to configure our design and import the data, schema, from our data sources, our metadata. We then take a step back and consider the business context using our business modeling feature before using this to define a physical model, for example, a data vault or dimension model. You don't need to do everything per se, but this is our default workflow. And this session obviously focuses on the modeling concept and how we can use that for great effect. The resulting design will be compiled in our development environment using the BI markup language and our integrated development environment. This will produce data logistics artifacts native in the target technology. For example, mapping data flows, SSIS, SQL, and the like. These artifacts can be integrated into DevOps pipelines to update modern data integration platforms and data solutions. But let's take a step back and consider what we're actually trying to deliver. A data solution, such as, for example, a data warehouse. Let's take data vault methodology, for example. For various reasons, there are many flavors of data vault going around. And an important early point to make is that the structure of a data solution doesn't always say that much. If it looks like a data warehouse model, and it swims like a data warehouse model, and it quacks like a data warehouse model, you think it's a data warehouse, right? But in this case, it doesn't really qualify as a data warehouse in all cases. Having a certain model structure does not necessarily mean that a given methodology is implemented correctly. In other words, the model structure itself does not mean being compliant with all aspects of the methodology. Looks can be deceiving. It also makes for a great way to show how the modeling starting point changes the outcome, and to what extent data warehouse criteria are satisfied when you do so. But first, we need to define what the data warehouse is. When it comes to defining what a data warehouse is, I'll refer to some key characteristics as originally provided by Bill Inman. While there are various definitions, this one seems to remain the most popular, and it definitely serves our purpose here. In this definition, the main themes are that the data warehouse is subject-oriented, meaning that the data is organized for a specific subject area or goal, as opposed to based on how the operational systems that provide the data organize it. It's integrated, which means it's consistent in conventions and, of course, the ability to bring together disparate data sets from various places. It's non-volatile, which means that once the data processed, it's not modified again. And time variant, which means there's an element of time associated with the data, and it can be analyzed in, for example, time series. And it's interesting to consider how these requirements apply to the model when different starting points for the design are chosen. To explain this, let me show you the following example. Let's say there are 3 operational systems involved in a new data solution initiative for a given company. Got an HR system that organizes employee records for each store. Separately, you've got this asset management system that manages lease and maintenance and upkeep. So really focused on building maintenance. There's also the finance system, which manages the general ledger, so expenses, balances, budgets, and the like. And when it is time for planning, HR provides operations with Excel sheets, and you've got some automated processes happening between finance operations. There's all kinds of things happening between the systems that we may know and we may not know, may not be aware of. So if we want to build this into an integrated data set using data vault methodology to build ourselves a data warehouse, there's a couple of high-level approaches we can take. So we can approach this from a source perspective using source-based models, which are really building the solution based on the available data. We can use industry reference models and ontologies that have various levels of abstraction, or we can use a more business-driven approach using the collective understanding of the business model and the processes between all the involved parties. Source-based approaches are popular by software vendors because they allow for immediate and recognizable results, because you derive a physical model for your data solution based on the structure of the data that you have, for example, by using primary key information and foreign key references. This makes the data source look like a data vault, but it's created from a technical perspective and more biased by how the operational system organizes its data. Generally speaking, the resulting model doesn't fully represent the business view of the data. Often there will be issues related to managing model changes over time, as we'll see later. Alternatively, some organizations opt to use industry reference models to kickstart the modeling efforts. Industry models tend to be more generic and abstract, and it may not always align to how your company operates and refers to things. Although different levels of abstraction can be considered, the resulting models tend to be more generic using less familiar names. And this can lead to issues delivering the data, as we will see later. And last but not least, a common approach is to workshop a model, drawing from the understanding of everybody involved, the business and its processes. This business model is more likely to contain definitions and terms that are familiar and meaningful, at least to the involved teams. These models tend to be stable because they're modeled after the business processes, which don't evolve as often and as fast as the systems do. Depending on which starting point you choose, the model that you get may turn out to be very different, at least in the beginning. From a Benelux perspective, it doesn't really lock you into any of these approaches, but we do provide a couple of structured ways to get the best outcome for your individual situation. The first approach, if we look at the data set that we have from a source-based or bottom-up view, it uses the available data, the primary keys, the foreign key references, to derive a model for the specific target methodology, such as Data Vault in this example. However, this model will be created from a technical perspective. So store and employee can be created as their own business concepts, hub store and hub employee. And when directly relying on the original data and its metadata structure, you basically get a data vault version of the original data. And the added value of this model may be limited, and it may be more effective to simply work with a historized version of the original data, for example, using a persistent staging area. If we add additional sources, these will be created as separate business concepts. There's no systematic way to relate account from the finance system to a store or a branch. With some effort, we may be able to establish a relationship if we also take into account the Excel sheet. It's not really integrated. Each concept is modeled as its own hub business concept entity. It's not really subject-oriented either for the same reasons. We do follow standard data vault patterns, so we do record timestamps and satisfy the null volatility and time variance requirements. We can take that a little step further, but arguably it's not really integrated either, even though we can use Excel sheets to establish relationships between core business concepts in our model. It's questionable. So the other approach is to use industry reference models. And we can talk about a party, which can be a person or a company or an arrangement, which will result in a very abstract data warehouse model. And of course, there's different levels of abstraction we can select here, but in most cases, these terms will be are more likely to be less familiar for the people involved. Reference models are provided by software vendors or described in data modeling books, or can be purchased, or you get them as part of a consultancy package. But as I said, using industry reference models may lead to a data solution model that is not necessarily meaningful for the team working with the model. And from a data vault perspective, it makes you wonder what's happening here. Is there a relationship between party and arrangement? Is that a working agreement or a building lease? And the relationship between party and party, is that between an employee and a manager, or a service agent and a customer? To understand what the data means, there's a lot of role playing involved. We can describe a lot of things as party, but we don't know what we're talking about. Getting data out of these kinds of models will involve a complex set of queries that include a lot of self-references. In any case, the model itself doesn't really read as well. Looking at the data model, it's not exactly clear what's happening here. We have a way to avoid the bias that can creep into some of the designs if we look too closely at the source data, and we can take the proverbial step back and look at what's happening in our business and start using names like that. So for example, the principles of employee, branch, store, account, if we workshop this and discuss this as a team, we might be able to say that store and account are really the same as branch. By initially discussing more generic definitions and terms and considering the business processes, a model is created that is elevated from the the way the data is physically recorded in the production systems. Business modeling workshops identify what type of things are being used in the business and how these interact with each other in a way that's not directly tied to the technical way those elements are stored in the data. So what we can do here is if we look at this information and we say store an employee, that's still an employee, but we've established through our business model that we really want to call this a branch. And this means that if we start adding more systems, these are immediately integrated in against the branch model. Based on the conversations and workshops, it is found that all three systems work with the concept that can best be described as a branch. Functionally, they mean all the same things, and acknowledging this results in the model we see on the screen here. Note that account and store are integrated into the branch concept. So both datasets will load into this branch entity automatically, and by virtue of this, they are automatically integrated, which is a concept known as passive integration. So simply by modeling the information better, we don't need the Excel sheets anymore. We don't need to rely on additional interfaces. We've already established that these things mean the same, and the resulting data integration logistics that are generated by Bimmelflex will do the heavy lift for you and make sure that this data gets made available. And if desired, the descriptive information, the context, can still be separated in the data vault so that the original data is preserved for each system that provide the data if you choose to do so. If we look at the differences, so we've got the business model version here and compare it to what we would get if we would model the source. Differences are striking. Bimmelflex offers a business modeling feature to provide a structured way to allow teams to work together on the business model in a way that mimics the real life in-person workshop experience that you would have by putting post-its on the wall and moving around discussing. We want to support and enhance that way of working and use the outcomes of those workshops to drive the design of our data solutions. There are a number of structured ways to do business modeling. One of them is, for example, ensemble logical modeling. Bimmelflex allows you to configure how you want to set up and do business modeling for your teams. Initially, you start by capturing all the involved business concepts or entities. You organize them, you make sure that there are no duplicates, that business concepts are really business concepts and not properties of something else. You make sure that the concepts are related to things that are happening in your business, the events. So you associate concepts to events, and then you produce a diagram where you can create additional associations if there is a relationship between things that is not directly tied to a transaction or an event or a thing happening. We call that a natural relationship. First thing is to capture all the involved business concepts. So what we can do is we can put everything that we find on the screen, and we can start making sure that all the duplicates are removed. So we can do this by having a known as relationship, and we can add more. So we start to clean up this canvas in Bimmelflex to remove any duplicate entities that we have, which means that as a team, we're forced to standardize on using specific concepts. Then we need to look at concepts if they are properties of other ones. For example, do we have property here? This can all be done through the Bimmelflex app, and it gives us yet another cleaner board. We can then start to associate those concepts with certain events and remove the concepts that are not related for specific events. We don't remove the concepts themselves. We just say these things are not related to this event. And then we can split into header and detail if we want to. So we organize our concepts and our relationships in a natural way. And the last step is to display it into a diagram and to add any references that may not be directly related to an event, the natural relationships. So this gives an overview of our business modeling feature and how we use it and why we use it. The next steps for working with BIMLFlex and delivering the solution is to make sure that the imported metadata, so the structures of your data set, are mapped to the business model, so we can use that to generate the data vault model itself and any data integration processes that are needed to populate it. To summarize, we've looked at different approaches toward modeling reality and have seen the impacts these can have on our data vault solution. Having a business-focused view will keep our model manageable, and we can now map new data to existing generic concepts which are meaningful and familiar to us, and forward engineer the changes in the technical environment using our BIMLFlex solution. If you want to know more, please reach out to us, and thank you for watching this business modeling overview.